Hi, everyone. So we've got our second to last talk this afternoon in track one. We have Juergen Brendel telling us about deploying test and production systems with Ansible. He claims to be an architect, designer, developer with 20 years in the industry doing very cool things like working with supercomputers and low-level networking and some other stuff that he should probably tell you about because he'd be better at it than me. So here's Juergen.
Hi there. It's nice to see some people here in the afternoon, last day, almost done. Huh? So I'm Juergen. I work for Cisco, but what I'm talking about here right now is actually more related to some private stuff I'm working about. So as I said in this lightning talk, I'm really interested in this whole automated deployment tool chain and how you can get your local development and test and actual production environments to be all the same, so you don't get all these hiccups along the way. Now, when we talk about deployment, when we talk about the deployment of applications, we are really talking in a way about configuration of your servers and of your applications, right? Because what kind of configuration are we talking about? You know, you have to set up your system packages, you have to install your software, create your users and groups, and configure things and restart services, all this sort of stuff to get your application to run on some server. And that, of course, is a special case of configuration management. You go from one configuration, a blank server image, to a fully configured one, right? So how do you configure a server? There's this traditional way, which has been done for many years, where you have somebody who has all the knowledge how the server is being set up. It's a manual process. They know it. Nobody else knows it. And if this person gets run over by the bus, you have no idea how to recreate your server or how to set up your site again. You might manually follow manual instructions, which somebody has written down. That's a good step forward, but it's still very error-prone, obviously. So next step up, big improvement is if you write yourself a shell script, which you can just put on a server and it goes through various steps. But shell scripts have their own challenges. Like if you want to run them twice, are they really idempotent? Can they run twice without screwing things up? And then we have configuration management tools, which is basically a more systematic approach to exactly this question. Right? And there are a number of configuration management tools. The key here is that those last two here, the scripts and the configuration management tools, lend themselves to automation. And so they are scalable. If you set up one server or 100 servers, it's the same thing. It should just be one command for you. And so those two approaches are certainly much superior to the manual approach. Right, so configuration management tools are differing from scripts because rather than telling explicitly what are the steps that you should do, they are describing, in configuration management tools, you describe the desired state of the server. So you say, for example, like ensure that all the system packages are updated. You don't say update it, you say just make sure they're updated. And you don't have to do anything if they are already updated, right? Same here with make sure Apache is installed and that this user exists and that you have your sources cloned from your repository. This version of Postgres and this database created. So now the CM tool can now go with this sort of description of the desired state. It can go multiple times over a server. And if something has changed, it can bring it back into the desired state. But if something hasn't been configured at all yet, it can do it from scratch. And you don't have to deal with any sort of error handling and such because it takes care of this for you. So it makes for very short, compact descriptions. Easy to read and easy to use later on if you want to maintain your server configuration. So there are a number of tools out there. So it started with Puppet and Chef. And they are very feature-rich and very sort of enterprisey heavy these days. They feel a bit like you're working with Java. And so people thought that's just too much and not so nice anymore. And people have sometimes issues getting it all up. It's a pretty heavy sort of approach. So a couple years back, people started working on things like Salt and Ansible, where they said, hey, we can make things simple and simpler and make simplicity one of the goals. And Ansible certainly does that. We also have things like Fabric and scripts, obviously, but they're not really CM tools because they are very explicit in the way you describe what needs to be done. Right, so let's talk about Ansible. This is one of these CM tools here. We can use this to configure and deploy our servers. It calls itself an orchestration engine for configuration management and deployment, so that it already claims to be a bit more than just dealing with one server. It orchestrates, it can orchestrate between servers. It's actually one of the strengths of Ansible, and we'll see that in a little bit. It's written in Python, which is cool. And uses YAML to write down what it calls a playbook. And that is basically a description of the state you want your machine to be in, or also explicit instructions. You can add those in as well. And very recently, they have also started to support Windows, where remotely it uses PowerShell on a Windows client. So you can now actually go and use Ansible to manage Windows machines as well. It's brand new. I don't know anything about it except that it's available now, supposedly. Right, so key points: simplicity. There is no central manager. There is no central server that you need to run, like with, for example, Puppet or such. There's no, there's nothing that you need to install on the target machine. There's no agent that needs to be present there. And everything is explicitly ordered, so there's no surprise about in which order things get executed. So if you've worked with Puppet, or I think also with Salt, you sometimes have these issues that it tries to optimize things and tries to do things in parallel, and then you get surprises because one thing wasn't done before the other was expecting it. And with Ansible, you don't have that. Everything is just exactly in the order. So it's very, very simple. All it needs is SSH and Python on the machine. So now every sort of image you can pull up these days gives you SSH access and has Python installed. So it's you can bring up a brand new image on Linode or Amazon AWS and point Ansible at it, and off it goes. It can set up stuff. It needs no further installation ahead of time before it can be used. So the architecture is very simple. From my laptop, for example, I can run Ansible, and it reaches out straight directly to the machines I want to manage, and there's nothing in between. Very important part of Ansible are the modules. So there's Ansible, there's a core, right? which is the software that uses SSH and other things to communicate with these other machines out there. And then there are the modules. The modules are very small, focused, standalone little bits of code which are specialized in doing one thing. For example, installing packages, creating users, executing shell commands, copying files over, templates, operating in configuration files, setting up services, dealing with repositories that you have, even high-level things like communicating with message queues, or setting up your web server as a database. So these are very specialized modules. They are, for example, they are Postgres modules for Ansible, which know exactly how to deal with a Postgres installation. MySQL modules, Apache modules, command line execution modules, all sorts of modules, hundreds of them for different purposes. The stuff you might need in order to set up your system or your entire cluster inside. So this is how this works. You have your local machine. It uses SSH. It has a module locally here. I have a copy of a module which knows how to install stuff, let's say, right? And I want to install Apache. So it takes this module, this source code, this Python source code, and together with a couple of arguments, sends it over via SSH to the server, runs it there, returns the output, and then deletes the source code there. So Ansible comes to the server, puts a bit of code there, runs it, deletes it, and there's no trace left of it, and the installation has happened. So you don't have this big blob of Ansible-related software filling up your machine there. It's very lightweight in that way, so your machine doesn't have to have storage available for this. So it works on small systems as well. When you want to let Ansible go and manage things, you need to define which host it should deal with, and so you use an inventory file. And an inventory file, you can organize in groups your servers. So here we have 4 servers and also 4 groups, coincidentally. So you see, I've them color-coded to make this a bit easier to read. So I have a European server group and a North American server group. And you'll see that my front-end group, so up there's a geographic grouping. Maybe I need this for compliance stuff or whatever. And down there is functional grouping, front end and back end. And you can see that these groups, they can intersect, they can overlap, they can be supersets, subsets of each other, right? And then I can say, do these configuration tasks or the state here and apply it to this group or to that group, right? So Ansible allows you to, for example, run little ad hoc commands, single ones. So here in the first line, I'm getting the uname A output from all my European hosts. In the second line, I'll tell Ansible to go and run a reboot on all my front-end hosts, right? And just goes there. So it's a single line that reaches out to all the machines and does this command. But the single line ad hoc one is not really the interesting one. This is a very simple playbook. This is in YAML, describes a bit of a state that I would like to have on my target hosts. So first it says on which hosts, it says front-end, hosts front-end. So this applies only to my front-end host. And first thing is, the name there is just a user-readable line that gets output when I run this whole thing. Right? First thing, you see the apt there, name update the system. Underneath it says apt. That is the module that I want Ansible to use, the apt module. Install Nginx, or rather, make sure Nginx is at the latest release. Right? I'm not telling it install it. I'm just saying make sure it is there and it's the latest release. Also, make sure that this user there, app user, is present. And down there in the bottom, I'm taking a file, I'm copying it from my local machine to the target machine. You can use template processing along the way to fill in certain things. There are some variables that you can use. I'm defining a variable there, username, app user. And down there, I'm referring to this variable in my playbook. But of course, it's not very interesting to just define your variables up here and then use them down there. Here's a little project layout, a very simple one. You have down there on the bottom, you have my playbook file, site YAML. On top, you have a hosts file. These are my hosts. And in the middle, there's a directory called group vars, which is something that Ansible looks for, well-known name group vars. And I can define variables specific to certain groups simply by naming my variable file by that group, right? And so when Ansible runs, it looks and it reads the group vars files for all the groups that a host is a member of. And so on a given host, I have variables from the various group files that it is a member of. So I can have specific settings for specific groups. Right? So I can deal with this. This is a more realistic project layout. We have on the upper left there are two host files, maybe one for staging, one for deployment. I have group vars, and then I have host vars. I can actually also have variables that are specific only to specific hosts, right? Side files, and then on the right we have roles. And roles is this way for Ansible to package basically tasks and variables and files and templates, all this sort of stuff together, so that it can be reused, right? So rather than just writing everything into one big playbook file, you can use these roles to bundle it all together. So you can maybe reuse this in a different project. So you see there, for example, the common, there might be my basic setup of all the systems that I want to use. It has tasks and config files that it needs and a couple of scripts maybe, what I want to copy onto the machine. So my playbook then looks like this. On my front-end hosts, I just want them to do this role here, common, which has the basic system setup, and web, right, which maybe means install Nginx and configure it. My backend systems might have the roles common still, and then maybe DB, right, for installing Postgres and configuring that. So it becomes pretty well readable. You don't have everything all in one thing, and you can just reuse these things for different servers. Right now, this is something that I find is very important. Often you have these issues when you test and develop in-house, and then you want to deploy somewhere. Everything from we are using SQLite in-house for our testing, and on production we are running Postgres, and why does this not work, and those sort of things. And so different developers are asking, how can I get my development environment up and running, and why is your development environment different than mine, and those sort of things, right? So these are some of the results of this. You can't catch the bugs, and you can't reproduce the issues. Maybe you have some test servers, but they are currently busy and full. You can't use them, and it works for me. It's very, very. We've all been there. So what we can do here is to fix this. It would be great if you just have a single command which can bring out our development and test environment, and also a single command to bring out an absolutely identical staging and deployment environment, right? And we can do this now. We have lots of tools. We've seen lots of talks which mention this. But what I use here is Vagrant. We all know Vagrant, right? It sets up a bunch of virtual machines on your local machine. Very useful. And then you can use the same site configuration, the same site playbooks that I use to bring up my production system, I can use this to configure my local VMs for development, for testing, and staging. So in Vagrant, you have the idea of a provisioner. So after a virtual machine has been spun up, it starts a provisioner. By default, I think it uses a shell, but you can also tell Vagrant to use Ansible. And then you just provide some parameters. You provide a pointer to the playbook in question, and off goes Ansible and configures your machines in exactly the same way that it will configure a production site, right? And a new developer joins your organization. The only thing they have to do to get a development and testing environment that's the same as a production environment is type Vagrant up. And that's pretty neat. I had a whole bunch of examples and Vagrant files here, but I had to take it all out because it would have taken half an hour too long to talk about all of this. Right, this is, now we take Ansible a step further, and we will make it interact with infrastructure as a service. But before we get there, we have to acknowledge that really a lot of what we've seen has become possible because for a couple of years now we're having this trend in our industry where everything gets APIs. That's incredibly useful. See, we all know local APIs. You have POSIX on your machine, and even the command line in a way is an API which you can use programmatically. But for a couple of years now, we have seen infrastructure as a service, obviously, and services as a service, so driven by APIs. I think that's awesome because now we can take. See, we have CM tools like Puppet Chef, but Ansible, obviously, I like Ansible. We have those CM tools, and they interact with APIs on a machine. Like they go there, they interact with it, they do stuff and set it in a certain state. Well, if you have APIs and all of these things, you can now take the very same paradigm that you used to set up your local machine to do much more. To set up not just your local machine, but to set up to bring up your entire infrastructure. Ansible can talk to Amazon or Google Cloud or whatever and say, make me some machines. Oh, let me configure those machines. Because Ansible can do that. It can go to machines and configure them. But it started out by creating this infrastructure out of thin air, then configuring it, then wiring up with some of the servers, maybe creating one of the load balancers that Amazon has or something like that in front of it, then putting all of this together in an auto-scaling group, and then in the end, creating an entry in Route 53 or the DNS, whatever it is. And suddenly you use the very same tool all the way from creating your data center all the way to configuring the servers down to the individual config parameters in your config files. So you don't have this tool break. You don't have use this tool for this and this tool for that and this API for this and then different things, right? Use the very same tool. And Ansible gets us there because it has support for a ton of these cloud interfaces, public and private ones. I've worked with the, experimented a bit with the DigitalOcean and the AWS one for the public and the OpenStack one for the private ones, but it has modules basically for all of these things. And with every release of Ansible, more of these modules are being added. So that you can set up your entire compute environment and data center using Ansible. For example, when we look at the AWS ones, it has infrastructure-related ones to create instances and images and the VPCs and load balancers, but also for a number of the services that Amazon offers. And so you can wire this all together because it's part of the same playbook. How do you do this? Well, you start out, for example, by creating your group file again. Here's a group file. But what's missing? Your servers are missing. There aren't any servers there. You're just basically saying, right, so I'm creating this group, I'm defining these groups here, and they're currently empty. And then you're using something like this. You're using the EC2 module, the Ansible EC2 module. See how it says local action? Local action just means I'm not going out to some server here, I'm just running it locally on my machine. This can be part of your playbook now. Local action, use the EC2 module. Here's my key, security, this instance, this machine image, which is some Ubuntu server or something. In this region, make me 3 machines. And EC2 is pretty fast, so like 30 seconds later or so, these machines will be up and running and available for you. And then I use this register keyword there. That is a way to store a variable in Ansible, to store basically the result of a module action in a variable. And what's in there, these variables, they're always dictionaries. And there's a lot of stuff in there. Amongst them is a list of all these instances, these IDs which Amazon has created. And then down here we see there's a lot of information for every single one of these instances, right? And now I can iterate over this. See there, local action, we are using the module add host, which is a module to add a host to a group. Our groups were empty, remember? So now I'm iterating over it with items that you see in the very bottom. That's the Ansible way of iterating over stuff. And I'm referring to the EC2 results.instance list that we saw a moment ago in that dictionary. And you can see there's a host name. I'm putting the public IP attribute. Go back here, see there's a public IP attribute. I put the public IP attribute into the group. And with that, with these two commands there, the EC2 create and then with the add, I have my groups populated, and then everything else can continue as before, right? So infrastructure created out of thin air, and then the usual configuration steps applied. So Ansible is written in Python, so you can contribute to it. And in fact, you can extend it for your own purposes. Thinking about this, I'm wondering whether or not Ansible might just be the perfect open source project if you want to get into contributing to open source project. Why? Because all of these modules are very small, totally self-contained, no dependencies. So you can be a useful contributor to the project by taking, oh, I know about some API, making a module out of it, maybe just a couple lines of code, and contributing it to the Ansible project. Now, you can actually write these modules in any language. They don't have to be Python. Whatever can be copied to a machine and can be run there will work. But if you want to contribute it to the official project, not just use in-house, then they prefer Python. So let's take a look at how you write one of these modules. Well, first of all, you set up your environment, right? You clone down the sources. You set up the environment set up there. That's not even a virtual env, just a couple of environment variables, that's all. You start writing your module. We'll see an example in a moment. In the end, they have this little test script, test module it's called, which you can use to run your Ansible module from the command line and to give it a couple of parameters, and that's all. So here's a very, 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 very simple Ansible module, which does nothing useful. It just takes a local time, and it returns some dictionary. All output in Ansible modules has to be in the form of a JSON dictionary. You shouldn't throw exceptions, you should catch them. And you should indicate whether or not you have changed the state of the resource or not. So that's why there should be a changed true or false as part of what you're returning, right? And then, of course, you can return additional information as well. You can write your modules like this, or you can use some convenience modules that Ansible provides for you, which make a couple of things a little bit easier. You don't have to use them, but you can. It's pretty useful. So in a full-blown Ansible module, you would have a documentation string, and you would have an example string as well, which I haven't even shown yet. And that would be taken in order to auto-create actually the documentation on their website. Here's a module that I wrote. See, I'm importing a couple of convenience methods up there, and color-coded again here. The presence of these convenience modules allows me to define my argument spec. Basically, I'm expecting these sort of parameters of this type. These are allowable values and so on. You can do this there. I can read these parameters. And the point of this whole little test module is to write a couple of characters into the beginning of the file, of a file, right? The beginning of a file overwritten with a couple of parameters. So in the red part, I'm checking, does this file exist? If so, I'm reading from there a couple of characters, and I compare it to the data I'm supposed to write in there. If the data is already there, if it has this data already, then I can use this exit.json. I could also just print to standard out, the JSON thing as we've seen before, but I can just use this convenience function exit.json there, say changed false. I didn't have to change it, and a bit of other data. Otherwise, I am opening the file for writing, and I write these bytes into the file, and then I return JSON changed true. It has changed now with a couple of other stuff. In all other cases, maybe an exception was raised, I'm returning like this. So if you want to write your own system setup stuff, if you have knowledge about an API or steps that you take through system configuration, you don't have to just write a random shell script. You don't have to just, you can actually write it in this form, and then it becomes usable in Ansible. And as you can see, there's not much to it to tie it in with Ansible. So if you're looking for a way to contribute to an open source project, Ansible might just be the ticket, because you don't have to learn a whole lot of dependencies. And that's pretty much all. The last link there on the bottom, that is basically, that's an example which I wanted to show, which I didn't have time for, which basically sets up a full cluster of a couple of machines and a load balancer and stuff like that on Amazon EC2. And so you can go there and check that out. Great.
Does anyone have any questions?
Yes?
Yes. Hold on.
Ansible sends Python or shellcode, I guess, to be executed on the server you're setting up. Has it got some kind of clever minimizer that it uses, or is it just going to?
I'm not aware of that, but they are using clever pipelining of requests, which used to be much slower, and now it is much faster, and so that's good.
So we are using also Ansible in prod for like 3 or 4 months. We have like a lot of playbooks already. And are you using Ansible Tower or something to like?
Yeah. So Ansible Tower is a way to more centralize, manage your Ansible playbooks and stuff. And no, I personally haven't used it. There's also Ansible Galaxy, which is a repository of modules which you can use from. Yeah.
So how would you like have your playbook somewhere so it's more readable for devs to?
Well, currently my playbooks are checked in with the rest of the project in the version control. So the developers can also see the necessary playbooks to deploy this. But since a lot of these playbooks actually are useful in a more generic way for multiple ones, there's actually a created main repository where they're all in, and then various projects can use either a fork or a modified version of these. Yeah. But that's more an organizational thing, and every organization will have a different way of.
That's what we are struggling with.
Yeah.
For it to make sense everywhere.
Well, currently I have a deployment directory in my project directory, and that everything is in there. Because it's still a lot of developing going on, so it's good to have it close together. Going once, going twice. All right. Thank you.
I had a question.
Yeah, yes.
When you were doing the EC2 demo, it generated a variable, and then you were doing a local action. Does that write out to a new group file that then gets saved locally, or where does that data ever get saved?
That's in memory, but you can dump your generated group files. So that's actually a good question here. You're referring to this part here. I get all the stuff back from Amazon, and then I'm putting this into my groups. Yeah. So this is currently held only in memory because it's only for this run, but I find it convenient in case this gets interrupted and I need to maybe rerun things, or I need to log into stuff to know which machines actually were created. And so I'm using a little function to dump the current group. You can do that with Ansible, to dump it into a certain file. But it's not done by default, but it can be done as an extra step. Yeah.
Anyone else? Great. Thank you very much.
Okay.